All right, class. In this video, we work example 6 in your note packet in a section on implicit differentiation. And so we are going to find the derivative of y with respect to x of this equation right here, right, using implicit differentiation. And again, from like the previous examples, 4xy, right, is a product of two functions. Remember, y is a function of x. So we got the first function, 4x, times the second function, y. And so we're going to have to use the product rule again. And remember, the product rule says if I have product two functions, a first function and a second function, right, one way to find the derivative is this form of the product rule. Right? Derivative of the first function times the second plus the derivative of the second function times the first. Okay. Now, some people will switch the order of multiplication, right, in those two terms, and they might even switch the order of addition, right? Switching multiplication, order of multiplication and order of addition, right, doesn't change the result. So here's our equation: x cubed plus 4xy minus y squared is equal to 5x plus 2. So we're going to differentiate both sides of that equation with respect to x. And from the sum and difference rule, we can differentiate each of these terms, right? Term by term. And so the derivative x cubed by the power rule is 3x squared, right? Bring the 3 down front, subtract 1 from the exponent. Now, in differentiating 4xy, 4x is the first function, y is the second function. And so we got to use the product rule from page 22, right? Basic rules of differentiation. So derivative of the first function, 4x with respect to x, is just 4. Then we multiply that by the second function, y. Then we add to that the derivative of the second function with respect to x. Well, the derivative of y with respect to x is denoted dy over dx. And then we multiply that by the first function, 4x. So this 4y plus dy over dx times 4x is the derivative of 4xy with respect to x using the product rule. And then we have to differentiate minus y squared with respect to x. So bring the 2 down front, we have minus 2y, and then we got to multiply that by dy over dx, the derivative of y with respect to x, because we have to use the chain rule in finding that derivative. On the right-hand side, derivative 5x, right, is just 5, right? Derivative 5x with respect to x is just 5, and the derivative of a constant is always 0. Now we got to group like terms, right? Isolate the dy over dx on the left-hand side, right, in order to find the derivative of y with respect to x for this equation. Well, this term contains dy over dx, and this term contains dy over dx. So we're going to keep those two terms on the left-hand side, right? So I have dy over dx times 4x is switching the order of multiplication, same as 4x times dy over dx. And then I have the minus 2y times dy over dx. 3x squared and plus 4y, they're not being multiplied by dy over dx. So both those terms get moved over to the right-hand side via subtraction, by means of subtraction. I subtract 3x squared from both sides, right? And I end up with minus 3x squared on the right-hand side. And I subtract 4y from both sides, and I end up with minus 4y on the right-hand side, okay? So I move 3x squared plus 4y to the right-hand side via subtraction, by means of subtraction. Well, now on the left-hand side, I got the difference of two terms. Dy over dx is a common factor, so I can factor out the dy over dx now. Okay? So I pull the dy over dx out to the right-hand side, and what's left in parentheses is 4x minus 2y. So when I factor the left-hand side, pull out the dy over dx to the right, I'm left with 4x minus 2y in parentheses. And how do I know I factored correctly? Because if I distribute the dy back inside the parentheses, I end up with this up here on the left-hand side. And I still get the 5 minus 3x squared minus 4y on the right. Now, I have a product. What it does, multiplication, division. So now I divide both sides by 4x minus 2y, and I end up with the answer. When I divide both sides by 4x minus 2y, this goes away. I'm left with dy over dx. The derivative of y with respect to x is equal to 5 minus 3x squared minus 4y over 4x minus 2y. And we're done.